were starting this factoring in this section by grouping stuff and splitting stuff. And I think we were on example 4 here. So, I think we got through the first one here. Now, I'm going to put a star up here by example 4, and you might want to do the same. I'm not going to get too picky about it, but I will tell you that when you get into big ideas, your answer might look a little different than what they're going to put in there, and I'll show you why here in a second. Okay? But how about a volunteer to walk me through how we were factoring this stuff yesterday? How are we writing this as a product of two binomials, right? Logan, help me out, kiddo.
Take the -9 and the 2 and make an arrow underneath the 3.
Okay, so -9, -2 would be?
You times them to -18.
-18. So we were looking for two numbers that multiply to -18, and at the same time they add up to what?
-3.
So I said, well, circle these values kind of right in here. And can you guys think of two numbers that would add to -3 and at the same time multiply to -18? -6 and 3. Good, Alexis. So what we do is use that -6 and 3 to rewrite my middle term right here, 3x. So we call this -9x squared. Okay, we're going to replace the 3x with what, kids? What two terms?
-6.
-6x plus 3x. That was these two values up here that we cornered off of our calculator. Okay. And then what's the next? Ooh, I made a mistake. Where's my mistake, kids? Yeah, I forgot 3x, didn't I? All right, good catch, guys. All right, so now what do I want to do here once I have that process complete? We were going to have two terms on the left and two terms on the right. And then we're going to do what's called factor by grouping here. Now, guys, over on the left here, highest degree, what kind of sign do you have? So it might make sense to factor out a what first? Okay, so we're going to factor out a negative what, kids? And when I do that, -3x factors out. What's -3x factored out of -9x squared going to get? Yep. Got to be careful on this next one. Kids, when I take -3x from -6x, what's that going to get you there? +2, right? Now, kids, this is the part that can be tricky with some of this. This is a pretty darn tricky problem. So, I see 3x and 2, and I can't think of a factor that'll come out of those. If you can't think of a factor that comes out, the only possible one is what? 1. So I have to write this as +1 times what, kids?
3x.
Okay. Now I'm going to ask the question here, kids. Are we on the right track? And if so, how do you know? Yep, these two parts right here, and then the parentheses, those two binomials match, so 3x plus 2. So what we did is the parts that weren't in parentheses, we made them their own group. So what did we call that? What part's not in parentheses? Isn't -3x not in parentheses and 1 not in parentheses, guys? So we would make that its own group. So this is going to factor into -3x plus 1 times 3x plus 2. Now if you guys get there, I'm going to be really, really happy because that's really good. Now one thing that Big Ideas is going to do, and when you're checking assignments, this is what they're going to do. Guys, out front here, what kind of a 3x do I have here? Okay. And they really want this other 3x right here to be a positive, but in our case, when we factored, what did we get? Negative. So just make a note down here. Here's what they're going to do. They're going to take this negative and move it to the front of the parentheses. But if I move this to the front of parentheses, if I negate the front side, what do I have to do to all signs in this part right here then to make this a positive 3x? Yeah, so this is really going to be the same as negative, whoops. Negative, whoops. This is going to be the same as negative, so this -3x would become a positive 3x. This +1 would become what, kids? That's what they're going to change that to, because they're going to try and make that 3x in here positive. Now, if you get here, I think if you put this answer like we have up here, when we got done factoring into Big Ideas, I think you should be okay. Just realize that if you see an answer that looks like this somewhere, This and this are the same thing, because if I bring the negative sign here, what's the opposite of 3x, kids? And what's the opposite of -1 here? So isn't this first part exactly the same as this part? Are they going to change the second part at all? No, because the 3x is already what, kids? So they might write it in factored form like so. Okay. All right. You guys talking through the next one. Someone I haven't heard much from lately. What value should I put under the 7?
6.
6. Okay. Sam, two numbers that multiply to 6 and add to 7.
6 and 1.
6 and 1. All right. 6 and 1. So I'm going to write this as -3x squared. Does it matter what I put first, the 6 or the 1? That's why I love this. It makes no difference what you put first, because you're still going to end up with the right stuff. What do you want to put first, kids? 6x plus 1x minus the 2 here. You guys, how many are like, I understand this process right now. Can I tell you something right now? We have 2 sections left to go in chapter 2. And what we're doing right now is going to allow you to do the same exact thing in the next 2 sections. So that said, I'm going to kind of shorten the next 2 sections a lot, okay? Because I think you have a pretty good idea on this. This is what I love this method for, because it works for everything, all right? And I'll show you that tomorrow. Split, what do you want to take out the left? All right, roll, kids. X minus 2, lovely. What do you want to take out of the right side, a positive or a negative? What's the only thing I can take out again?
1.
Are we right? Yeah, so this is going to become -3x plus 1. That's going to become its group. Times what, kids? No, x minus 2. How might they write that -3x plus 1 there?
Negative parentheses.
Yeah, they might throw this negative out front, and they say, you know what, this is really the opposite of what, kids? Times what else? There you go. You guys have got this. Okay, just give me a show of hands. How many are feeling comfortable about at least the process right now? Okay. And you remember where to go to get these values that we're putting up in the corner here, kids? Everybody good on getting to that length? Okay, sum and product, sum and product, sum and product. Okay. Well, guys, one more example, and I want to turn you loose on a few things. Any questions to this point right now? All good? All right, let's rock and let's roll. Last example. You gonna volunteer to read this for me?
The length of a rectangular skate park is 2 miles longer than twice the width. The area of the park is 84 square miles. What is the width of the park?
Okay, so first of all, what shape, kids?
Rectangle.
Rectangular. Let's draw this. There's my state park. Okay, might be Parsons Palisades, something like that. I don't know. If I have a park, it would be water parks seem to make a lot of money, don't they? I might have a water park. All right. We don't know what the width is, so what should I call the width here, kids? Don't know, so I'm going to call it x. Oops, didn't want to do that. This is what I want to do. The width is x. Now, guys, it goes in here and says that the length is 2 miles longer than what? Well, what would twice the width be then if we called the width x? 2x. And what would 2 more than 2x be? 2x plus. Okay. You're told that the area is how big, kids? Okay, our job right here, figure out what the width is. We got to figure out what x is equal to. Okay. Well, guys, when they start talking in terms of area right here, our job is to understand first of all what the area formula of a rectangle is. What is the area formula for a rectangle? It is length times width. So what I need to do is say, well, I know that x times this quantity, 2x plus 2, must equal what value, kids? Excuse me, yeah, my length times my width has to be 84 square miles, right? All right, help me distribute on the left. What's the x times the 2x, kids? 2x to the second plus what? And that's going to equal 84, right? Okay. Now, guys, we've talked about being able to factor and solve equations using factoring, but we had a certain product. We always had to make sure that our equation was equal to what value in the end to be able to make that work? 0. So in order to make this equal to 0, what are you going to have to do to both sides to proceed? Yeah, so we're at the point right here, kids, where it says 2x squared plus 2x minus 84 would equal 0. Okay? Now when I get to this step right here, do we know rules of factoring now? Okay, we're going to go 2 times what value first here, kids? 2 times what? Negative 84, right? Which I believe is negative 168. So somebody jump into their calculator for me in big ideas. We've got to find a value that adds to 2 and multiplies to negative 168. I think I know it, but you guys tell me if I'm right. Well, negative 168 is the product, and positive 2 is the sum. Is it 14 and negative 12? Okay, so we got 14 and negative 12. So let's go down here and rewrite this equation for 0. We're going to factor that left side, and we're going to be able to set both parts equal to 0 like we have in the past and solve this. So talk to me, kids. This becomes 2x squared. How do I want to rewrite my middle term 2x using these values up here in the top right?
Plus 14. Plus 12.
Minus 12x minus, and that's still equal to what value, my friends? Okay. Oh, let's talk split. So we go karate chop right here. What do you want to take out the left? Don't say the trash. 2x on the trash. Take the 2x out, good. You guys must be tired today because no one's laughing. 'Cause I know my jokes aren't that bad. All right, 2x is coming out. What do I have next, kiddos? X plus, yeah, good. Now with a little bit of luck, we might get lucky over here on the right side and say, ooh, we might be able to figure this out. First of all, am I taking a negative or a positive out of the right side?
Negative.
Anybody know what the largest number would be to take 12 and 84? This is where it gets kind of tough. Turns out 12 goes into both of them. Anybody want to guess how many times? Yeah, we got to get lucky enough because we know we have an x in here, so I got to have an x right here, so I've got to take negative 12. We would have x left. How many? But anybody want to guess what negative 84 divided by negative 12 is? Yeah, plus 7. Boom. Okay, let's talk, kids. So in factored form, this would become 2x minus 12 times x plus 7 is equal to what value? And by 0 product, this means either the first quantity is equal to 0 or the second quantity is equal to 0. So my question to you, kids, is this. We're trying to find the width, and we defined the width in our diagram as what variable? We defined it as x. So if I can solve for x, won't that get you the width? Okay, check it out here, kids. Do you know what value would go in for x to make this equal to 0? 2 times a number minus 12 is 0. Okay, x could equal 6. What would go in here? All right, quick question here, kids. I know we have 2 possible answers right here. Which one are you probably going?
6.
No, 6. Doesn't make much sense to have a negative distance, does it? Okay, check this out, kids. So the distance is 6 right here. We know then the width is, okay, let's see, our area was square miles, so that width would be 6 what? Right? Okay? Yeah, just for a little extra credit here, what's the length going to be, kids? What's 2 times 6?
12.
When I plug 6 in for x, 12 plus 2 more would make what?
14.
Gosh, with a little bit of luck, 6 times 14 might be what value? 84 square miles. Okay. Let me ask the question. Does the diagram make sense first when we draw a picture? Okay, do you understand why I had x times 2x plus 2 is equal to 84 to begin? In other words, the width times the length was 84. Okay, do you understand why I distributed and got this equal to 0? Once we had a trinomial right here, we know rules of factoring, and we find an x value of 6 and negative 7. Why did we choose 6 again there? We're talking about a real life problem, so we want to make it applicable. 6 miles is a positive distance. We don't want negative 7 miles of distance, all right? That would be a weird state park. Okay? All right, notes-wise, what questions do you have for me today? Anybody?